Hi guys, welcome to second lecture on metallic coating technique. During part 1, we have covered introduction to metallic coating, then anodic and cathodic coatings, different methods of metallic coating. Okay, so in part 2, we are going to cover remaining methods of metallic coating, that are metal spraying, vapor deposition, galvanizing, and its different methods, then anodizing and diffusion coating, and at last cladding. So let us begin with the first method, that is a metal spraying. It is also known as spray metallizing, and this technique involves the impregnation of base material with a metal or metal compound by spraying the coated metal or compound to the surface of the base metal, and the metal used for the deposition may be either in the form of wire or powder. Before coating, the surface of the substrate metal is first cleaned perfectly to ensure that adhesion of the sprayed metal and the deposition of the even it is uniform or uniform layer. Okay, and when coating material is used in the powder form, then it is known as powder metallizing or powder spraying, and when it is in the wire form, then the process is called wire metallizing or wire spraying. In both the cases, coating metal is atomized before the spraying, and it undergoes under a pressure on the metal substrate. So first we'll discuss about the wire spraying. In this process, special type of sprayed gun is used, and the spray gun consists of a gas torch, and the gas torch is connected to the oxygen and acetylene cylinder in the same way as in case of oxyacetylene welding, and the torch drawn mixture of two gases through high pressure in the cylinder, and it develops on the oxyacetylene flame, and the metal to be sprayed is fed into the gun in the form of wire, and the flame, you can see here, the flame at the end of torch melt the fed metal and it is atomized. Then the gun is also equipped with the another passage which is directly connected to the output of the air compressor. Okay, and then the air compressed air is coming out from the compressor, which carries the atomized metal particle onto the surface of the substrate metal with a very high velocity. And the velocity with high velocity bombardment of the particles is done by the maintain the certain distance from the substrate metal, and so these particles spread over the substrate metal surface. You can see here in this diagram I have shown the wire spraying, how the particle is going to spread over the substrate, and the sprayed molten metal cools down and freeze to the form a deposed layer. Okay, so you can see in this figure also the required thickness of the coated metal can be maintained by laying down many such layers over one over another. Okay, so this is about the wire spraying metals spraying technique. Let us discuss about the powder spraying. It is also known as a powder metallizing process. In this case, coating material is used in the powder form, and the coating material is filled in a hopper from where it is fed to the spray gun by suitable means, and the gas flame is used as usual to melt the powder. Compressed air is then used to atomize and spray the molten metal onto the surface of the workpiece in the same way as described in case of the wire spray. Okay, you can see here I have shown, and there is one more important technique of the powder spraying. It is named as a plasma spraying. In this case, plasma gun is used. Plasma gun is made of the copper, which carry the non consumable tungsten electrode, and the gun body is made of the doubled wall, and water is circulated between the walls to cooling the purpose. And a DC power supply is used to supply high intensity current into the circuit in which copper body is made an anode and the tungsten electrode as a cathode, and a high intensity arc is struck between the anode and cathode. The established arc is shielded with the help of inert gas, and the hot gas comes out from the nozzle of the body at a very high velocity in the form of very bright and shining flame, that is plasma, which carries a high heat intensity. The powder of the coating material is fed into the stream of plasma, which melt it readily and atomize it. The atomized molten metal is carried to the work surface at a high velocity by this plasma stream, and it will deposited there. And the wire gun, normally the wire gun process is generally prepared due to the easy availability of the coating material in wire form and the low cost of its operation. But powder metal by spray is denser and faster. Plasma coating is preferred in case of the coating of carbides of metals, titanium, chromium, oxide of zirconium, titanium, etc. Okay, so this is about the powder spraying. Let us discuss about the vapor deposition, or it is known as a vacuum metallizing. It is a vacuum deposition process. Any metal can be coated on a base metal through this process, and some non-metal can also be coated on the substrate metal. So you can see here in the diagram I have shown the process about the vacuum deposition. This process is very effective for depositing a thin metal film or film of a metal compound on a substrate base. Normally coating material used in this method are aluminum, chromium, silver, nickel, gold, platinum, germanium, etc. And the substrate material can be different metals, ceramics, glass, plastic, paper, and cloth. In this process, substrate, that is workpiece, and the coating material are placed in a high vacuum chamber. I have shown in the figure also. The coating material is heated by the electrical means, and due to vacuum, hot coating material atoms leave the surface in metal vapor form and condense at the surface of the substrate material. The workpiece is kept slowly rotating during the process so that entire surface is exposed to the advancing coating metal vapor. Okay, so this is process of vapor deposition. There are some advantages of vapor deposition method, which are I have listed over here. The first one is the thin coating of the metal is possible by this method, so little quantity is consumed here, and this method is most suitable for coating of very costly metals. Second is the decorative coating on household items are possible through this method. And the third is effective and low cost coating for corrosion and thermal resistance are possible using this process. Also, coating quality is usually assessed by measuring its porosity, oxide content, macro and micro hardness, bond strength, and surface roughness. Generally, in case of metal spraying, coating quality increases with the particle velocities. Let us discuss the next one, that is high velocity oxygen fuel spraying, HVOF. It is one of the way of metal spraying. In this case, a mixture of gases or liquid fuel and oxygen is fed into the combustion chamber where they are ignited and burned continuously. The generated hot gas at a pressure approximately 1 megapascal originate through a converging diverging nozzle and travel through a straight section, and the velocity of gases at two exit of the barrel extend the velocity of the sound, and a power feed stroke is injected into the gas stream, which accelerate the powder up to 800 meter per second. The stream of hot gas and the powder is described toward the surface to be coated, and the powder partially melt in the stream and get deposited on the substrate. The resulting coating in this way has a low porosity and high bond strength. Okay, this is the main point. HVOF has some application. It is recognized to deposit wear and corrosion resistant coating on the material. Again, commonly coating material like tungsten, cobalt, chromium, carbide, alumina, these are the common coating material. It is used for deposit coatings of required property of inserted tool bits. Let us discuss the important method, that is a galvanizing. Galvanizing is a process of applying a zinc coating to steel or iron components to prevent rusting. Again, our objective is to improve the corrosion resistance, and this galvanizing process consists of the four fundamental steps. First is the, as I have shown in this figure, one is the surface preparation, next one is the pre-fluxing, the next one is the galvanizing, and next one is the finishing. So these four steps one has to follow when he is doing or her is doing galvanizing. Okay, so in this figure I have shown these all four steps here, and the galvanizing is a electrochemical plating of a highly corrosion resistant material on the surface of another metal, and this technique is widely used to coat zinc over the iron and the steel. And galvanized sheet metals are available in the market for their commercial use also, and this technique is very popular and widely accepted due to its effectiveness and economy. A number of methods can be employed for galvanizing of a zinc to the metal substrate. So accordingly, this we have the different galvanizing methods. So first is the hot dip galvanizing. The first step of this process is cleaning of the workpiece, that involves its degreasing by acid rinsing followed by the water cleaning, and the second step is its annealing and cooling in oxide free atmosphere. And during cooling, when temperature of workpiece reaches near to the temperature of molten zinc bath temperature, the workpiece is dipped in the bath. A very thin and uniform coating layer can be maintained by passing the sheet through a roller just after the coating, and this method is not recommended for galvanizing of very delicate and complex shaped parts having complex interior design. So you can consider this a disadvantage of this hot dip galvanizing process. Okay, and here I have shown the hot dip galvanizing process, how one can do the hot dip galvanizing process. Let us discuss the Sherardizing. So this process is used for the galvanizing of those small parts having the intricate shapes, and in this process there is a box of containing or container having filled with fine zinc powder, and the parts are placed in this box surrounded with the powder, and the box is then heated in a oxygen. Zinc powder vaporizes and zinc wafer comes in the contact with the surface of workpiece, and the zinc is deposited on the workpiece. So this is process, and the workpiece is then taken out of ore and it is allowed to cool down to room temperature. In this way, galvanizing of workpiece can be completed using the Sherardizing process. Let us discuss the electroplating galvanizing. In case of electroplating galvanizing, zinc is deposited onto the workpiece by making it cathode. It is just like electroplating process. Working of electroplating already I have discussed, and this process is time consuming, so it is not recommended for mass production. Thickness of coating layer is very thin, so it is not capable to provide corrosion resistant property to the workpiece. This is disadvantage of this process. Let us discuss the last galvanizing method, that is cold dip. This process involves cleaning, buffing, degreasing of the work surface before galvanizing. Cold bath is used in this process. No heating of flow of current through electrolyte solution is required. The cold bath is prepared by dissolving salts like zinc chloride, tin chloride, ammonium chloride, and potassium bitrate, etc. in water, and it is filled in a tank. The tank used in this process is a metallic tank which carries a thin lining of rubber or PVC sheet on its internal surface, and during the preparation, proportion of the tin chloride should always be less than half of the quantity of the zinc chloride. So this point we should take during the cold dip galvanizing process. Let us discuss the anodizing. So anodizing is a process of deposition of oxide film on a metal surface with the help of anode and oxidation. The process involves cleaning of workpiece either in a hot soak cleaner or in a solvent bath. After cleaning, the workpiece is dipped in a electrolyte and made anode. The electrolyte used should give off oxygen on electrolysis. There is no any deposition from outside. When current passes through the electrolyte, a chemical reaction takes place and oxygen is liberated, which reacts with the metal surface to convert it into an oxide. In this process, a reaction progress inwards into the metal. The coating deposited is the integral part of the metal itself. So deeper the penetration of the chemical reaction, the thicker will be the oxide film formed. And after the formation of oxide layer into the third stage of this process is provide the desired color and stability to the anodizing film. So this is about the anodizing and the process of anodizing. I have shown in this figure. You can see here job work I have considered as the anode and the material to be coated that considered as an anode, and I have used acidic electrolyte for this process. So some of useful commercial examples I have mentioned here, that is anodizing of the steel is done to make it wear and corrosion resistant. Again, several galvanized machine parts are anodized to improve their resistance for rusting and corrosion. The main purpose of anodizing I have mentioned, so it provides protective coating on the metal surface which is corrosion resistance and wear resistance. Then again, to protect decorative appearance to the surface, we can go for the anodizing. Aluminum provides very good surface property after the anodizing. Let us discuss the diffusion coating or surface alloying. So the part to be coated are packed in the powdered solid metal or exposed to gases atmospheric containing the metal, and that to be coated. And the high temperature treatment causes the diffusion and may form a alloy. Sherardizing of zinc, chrominizing, calorizing, allorizing, that is aluminizing, then ferrosilicate are common example of this diffusion coating, and these coatings are relatively thick and are usually applied to the cast or machined parts such as hulls, wall guides and turbine buckets. Carbon steel, low alloy steels and stainless steels are the aluminized products, and here protective layer of aluminum oxide formed on iron or aluminum alloyed surface. Let us discuss the last process, that is a cladding. So it is a joining of two different metal or alloys by forming a strong alloy bond between the plates of the two metals, and the bond may be formed in many ways. For example, by casting one alloy against a solid plate of the other, and this thick composite ingots is then hot worked to reduce it to a useful form such as clad sheet, and the cladding is usually thin than the other material. The production of the corrosion resistance surface is the principal objective of this cladding process. And for example, alclad is to provide corrosion barrier to high strength aluminum alloy with a commercially a pure aluminum skin on the both side by rolling, because the alloy is susceptible to trace erosion. Okay, and it is very cheap method for protecting against corrosion, and cladding is also used for such purposes as making bimetal strips for temperature control devices. So these are the applications of cladding. So here I have covered all the methods of applying metallic coating. So here we'll stop. Thank you very much.
Hopefully you might have enjoyed the lecture. Then please do like the video and know your thoughts in comments. Please do share this video among your friends and don't forget to subscribe to our channel. After subscription, you can press the bell icon to never miss the notification regarding our new videos. Thank you so much.